Hi, I'm Leo Zhadnovsky. I'm a principal solutions architect at Amazon Web Services, and this is the Configuration Management in the Cloud webinar. Thank you all for attending, and we'll be discussing today how to take advantage of the AWS platform and the automation that it allows you to do to remove a lot of undifferentiated heavy lifting and be able to configure, deploy, and provision your instances and applications much faster. So, first of all, let's talk about the culture and process in general. So, configuration management is part of DevOps, and so part of DevOps is this concept called Kaizen, which really means continuous improvement. So, activities that continuously improve all functions involve all employees. And so, by standardizing our activities and processes, we aim to eliminate waste. And specifically, this is where configuration management plays into this, is configuration management allows us to configure our instances, also our infrastructure as code, and reduce having to do this manually, thus reducing the room for error by manually deploying things and increasing the velocity that we can do our deployments in. So let's take a look at how traditional on-premise configuration management works. You typically have either long-lived physical servers or virtual machines. These machines, because they're around all the time, you're deploying to them, so you're usually replacing the code and apps in place instead of building new images all the time. You typically have static DNS that points to each VM or physical server. And you have some kind of heavyweight configuration management system that's running on a static server. So now you have to make sure that your static server running your configuration management system is highly available and up and running all the time. There's also some challenges that come across with distributing keys and secrets. Ideally, you don't want to keep things like database credentials, API keys in your code, because then if your code leaks or your, say, chef recipes or private manifests get out there, then now you've leaked your credentials as well. So you have to think about, running a system to manage your keys and secrets as well. Additionally, the actual configuration management systems or libraries are often complex and take a life of their own, which means that you need specialized developers or DevOps engineers to run these configuration management systems. You also need unit tests and continuous integration, just like you would with your app code, but for your configuration management system. And this ultimately adds thousands of lines of code and complexity just to manage your actual machines or virtual machines. So the end result of this is that you're taking the undifferentiated heavy lifting that used to be involved with provisioning your data centers, power, network storage, and moved it up the stack. So now you're doing this work, which is necessary but repetitive, but now you're working on your monitoring, your logging, and your configuration management, and it's all difficult, repetitive work. But using the cloud is different. So one example of that is auto-scaling. So instead of having permanently running VMs or servers, auto-scaling allows you to meet your workload with fewer hosts during low periods. So you basically add capacity when you need to, when you have more traffic, and reduce capacity when you have less traffic. As a result of this, your actual hosts, your instances, they don't live as long. So a result of that is that you don't need to worry so much about patching and long-term maintenance. What you're doing instead is maintaining a set of images. So because you're launching instances when you get more traffic and shutting them down when you have no traffic or low traffic, you're building an image that gets spun up every time this happens, right? So you don't need to worry about having things or instances up and running all the time. So let's talk about some AWS specific services here that allow you to do this. So we're going to talk about AWS CloudFormation, AWS CodeDeploy, AWS OpsWorks, and AWS Elastic Beanstalk. So first, to see where they fit in. Uh, CodeDeploy and OpsWorks, they both handle deploying code onto your instances. Elastic Beanstalk, it handles provisioning your infrastructure and also deploying your code onto that infrastructure. And CloudFormation, it can actually work with all three of these services. So CloudFormation can can control CodeDeploy. It can define how your OpsWorks works, and your Elastic Beanstalk. So CloudFormation is really infrastructure as code. So essentially anything that you can do in AWS manually through the web console or through our APIs or CLIs, you can write a CloudFormation template for. We'll dive deeper into that in a little bit. So CloudFormation, what it allows you to do is it allows you to declare all the components of your application in a JSON or YAML template. And after you've done that, you treat this as your you treat this code as your actual infrastructure. So you get infrastructure as code. So you can do things like define your VPCs, your subnets, your security groups, your auto scaling groups, your load balancers, as well as your instances in your CloudFormation templates. You can also modify your resources in the template and then update your CloudFormation stacks to actually change your running infrastructure. So instead of having to manually do these changes through the web console, you can now just do them through the updating of your CloudFormation stacks. You can package your entire infrastructure in a single file. You can keep that file in your version control system, thus treating it as code. And you can share that file with your team. So for example, if you have a new developer coming on board and they need to spin up a new development environment that is the same as your production environment, instead of, typically when you have a new developer, it takes them a few days to onboard and to get all the stuff set up. With CloudFormation, you can just send them a CloudFormation template. They can launch that template in an AWS account and within minutes have a replicated environment. You can also do this across regions. And with the new CloudFormation Stack Sets feature, you can actually now control, you can have one template deployed to multiple regions and multiple accounts and control how that happens. CloudFormation also comes with two helpers. So there's CFN init, which is an agent running on your EC2 instance, and it's typically invoked on boot as part of the template creation. It reads instance metadata, which is stored in the template. It can then use that metadata to install files, run scripts, create users, start services, so on. Then there's also CFN Hub. So this runs on an EC2 instance as a service, and it'll check for updates to the CloudFormation template and can then run any shell script in response to change. So it's typically used to call CFN init to update configuration files or other settings when you've updated your CloudFormation template. So let's take a look at how to use CFN init. So in this example, what we're doing here is we are getting Chef and then running a specific recipe with Chef. So what's nice about this is instead of reinventing the wheel, we already have Chef. We're just using CloudFormation to kick off a Chef run. Let's move on to CodeDeploy. So AWS CodeDeploy allows you to deploy applications to Linux or Windows instances. It is similar semantics as package management tools, and it allows you to write scripts for lifecycle hooks. So for example, application stop, application start, before install, after install, validate service. And these hooks can be written in any kind of executable. So it could be a shell script, it could be a binary, could be a script that tells you to run your chef or puppet recipes. So again, you don't have to reinvent the wheel here. CodeDeploy also allows you to use different deployment strategies to implement rolling deployments. So CodeDeploy supports blue-green deploys. CodeDeploy also supports different speeds of deployment. So if you're deploying to a test environment, you've got 3 instances to deploy to. You can say, I want to deploy to all those instances at the same time. You can also, in a production environment where you want to be more conservative, you can do something like deploy to 1 instance at a time or half at a time. If you need to, you can also roll back to previous versions with CodeDeploy. And so this allows you to decouple your actual infrastructure from your deployment automation. Now let's take a look at Elastic Beanstalk. So Elastic Beanstalk is a very fast and simple tool, which increases developer productivity and gives you complete resource control. So Elastic Beanstalk, it spins up instances, auto-scaling groups, load balancers, RDS instances as needed. And as long as what you're doing is supported by one of the environments in Elastic Beanstalk, it's really easy to get up and running without having to worry about any of the underlying deployment or configuration management infrastructure. So again, Elastic Beanstalk, it allows you to it handles all the capacity provisioning, load balancing, auto scaling, health monitoring, and it currently supports PHP, Python, Java, Ruby, Node.js, .NET, and Go as one of its environments. And it also supports Docker, which allows you to be really flexible there, and custom environments as well. Let's move on to AWS OpsWorks. So OpsWorks handles configuration and orchestration of your instances and your applications on those instances. It handles the scaling and auto healing of those instances. It allows you to build each new instance to your specification according to chef recipes that you define. You can also change your instance configuration in response to different system events. So for example, here we have an app server, a DB server, and another app server. And depending on the sequence of events here, so we can have different things happen during different lifecycle events. So that includes executing chef recipes, for example. So as part of that, let's talk about what Chef Automate is. So Chef Automate is a product. It allows you to define your infrastructure as code using codebooks and recipes. Allows you to consistently install, configure, manage, deploy, and scale your applications, and allows you to align specific resources, so instances, ELBs, RDS databases with specific policies, and that saves you time by automating manual tasks. So the way that it typically works, if you're just using regular Chef Automate, is a simple client-server architecture. So you're connecting your instances to a Chef server. They pull configuration updates from that Chef server. So if you were going to set this up manually, you'd have to install the Chef server with your cookbooks and recipes. You'd have to install the Chef client on your instances. You'd have to register the instance with the Chef server as a Chef node. You'd have to assign that node with a role. So, for example, is it a web server, app server, database server? The Chef client then asks the Chef server for a set of recipes. The server determines the applicable recipes, and the client then applies those recipes on the node. And then this happens every 30 minutes. The client pulls the Chef server to see if there's any new recipes. So the downside of this is you have to maintain the server, and those steps are a lot of configuration that you have to do there. So we'll talk about how to do this much easier in a second here. But let's take a look at some example Chef recipes. So in this example, we are configuring Apache. So we're installing the Apache service and starting it. We are also adding a site configuration file to the Apache service. We're creating the default root directory and writing a default homepage to that directory. We're then installing the mod PHP module, as well as the PHP 5 MySQL module. And so that's typically how very basic Chef recipes work. So some things that Chef Automate gives you is it gives you visibility. So you get to see across all of your instances, the compliance, the cookbooks, the recipes that are used. You see a workflow. So it gives you continuous delivery. You can use it as a continuous delivery pipeline of your infrastructure and applications. And it also gives you compliance information. So it gives you a list of compliance risks across your environment. So as I mentioned, though, with running your own Chef Automate server, it's something that you have to manually configure and that you're responsible for. So let's talk about how to use AWS OpsWorks for Chef Automate. So what is OpsWorks for Chef Automate? So OpsWorks for Chef Automate gives you a fully managed Chef Automate server. So all those steps that I listed before, um, now you don't have to worry about most of them. So um, with the AWS Managed Chef server, in about 10 minutes, you can create a EC2 instance that has Chef Automate on it. You can set up a weekly maintenance window. You can use that maintenance window to have automatic security updates and automatic Chef version updates. You can also set up a daily or weekly backup schedule for the Chef Automate server. The backups are stored in Amazon S3. And so as a result of this, it's a fully managed configuration management service. So you can focus on writing cookbooks and recipes that meet your needs and not running your Chef Automate server. Some other benefits of the service is it handles automatic registration to the Chef server instance. It works with auto scaling, so as you get more instances or less instances, depending on what your auto scaling groups are doing, you don't have to worry about connecting them to the Chef Automate server. There's no separate licensing fees. You just pay for what you use. And it's covered under AWS support. So if you have a problem and use your AWS support on your account, you can get help on any kind of issues that you may run into. And so where does it come into the toolchain? So it bootstraps your instances with the right configuration. You can update the configuration of your already running instances, and you can assure that your instances comply with your predefined policies, which are configured in your chef recipes. And so this can be a part of your continuous integration and continuous delivery pipeline. So let's talk about some other tools that you can use. So one of them is EC2 Systems Manager. So EC2 Systems Manager is a service that has several options. Let's talk about the ones that are applicable to configuration management. So the first thing that EC2 Systems Manager has is a thin automation bootstrap layer. This allows you to do things like automatically join a domain when launching Windows instances, automatic installation of either PowerShell modules or MSI packages, and the configuration of custom CloudWatch metrics and logs. This doesn't replace PowerShell for Windows or Chef or anything. It's complementary to it. So you can use your systems manager to bootstrap either your PowerShell scripts or your Chef recipes, and then hand over to those tools for more in-depth configuration. As I mentioned at the beginning of this webinar, another challenge that you have is secrets management. So part of these two systems manager can help with that, and this part is called parameter store. Parameter store allows you to have centralized management of assets such as passwords and connection strings, and it stores those passwords and connection strings using your own KMS keys, so it's encrypted with your keys, and you can then reference these parameters either in the run command state manager automation pieces of EC2 Systems Manager. You can also reference them using the CLI or inside of AWS CodePipeline, which is our continuous delivery service, or really in anything because Parameter Store supports IAM roles, which allows you to manage access in a granular fashion, and it supports the CLI. So you can run a CLI command to pull certain key value pairs stored in the Parameter Store. So this ultimately provides you a managed service that can you use to store your secrets and be integrated into your configuration management pipeline. So let's also talk about infrastructure as code. So we talked about CloudFormation, which allows you to do infrastructure as code. But infrastructure as code, what it really is the ability to specify an environment um, without having to do any manual steps. So we're not talking about just instances here, but your whole environment, your VPCs, your instances, your auto-scaling groups, your RDS instances, and any other AWS services your application might utilize, the ability to define those as code. And once you have those written out as code, or CloudFormation templates, you can then also share those environments easily by sharing the CloudFormation templates. Some other things to think about when it comes to configuration management. So traditional security work is hard to scale. So traditionally, you just have periodic security scans, you have security engineers who manually scan things, but what you can do when you have configuration management is you can have your security checking as part of your infrastructure. So, for example, you can have common bits of your templates, of your CloudFormation templates, that are distributed across all your environments that ensure certain security standards. So, for example, you might want to have IAM users that are in all your AWS accounts. For example, security auditor role. You can have a CloudFormation template that defines that, and then use CloudFormation stack sets to roll that CloudFormation template out across regions and across AWS accounts. You can also enforce compliance using a service called AWS config rules. So AWS config checks your AWS account for different compliance issues. For example, you could check for instances that have the SSH port 22 open to the world. And then you can use config rules to automatically close that port. You can also take advantage of the Amazon Inspector service. The Inspector service scans an instance and then runs different security baselines against that instance. So for example, there's different packages you could run against it. There's a PCI package. There's various other packages on there. There's a CV package. So once you run, for example, the CV package, it'll scan your instance and it'll say, you have these software packages installed. They need to be updated because there's CVs against the versions that you have running. So that's great. But what you can also do is you can have AWS Inspector again as part of your application lifecycle management. So, for example, as you deploy your code, you could trigger a run of AWS Inspector afterwards to make sure that what you've just deployed using, for example, Chef Automate is compliant with your security standards. So this leads us to a toolbox approach. So you can use CloudFormation, the other tools we discussed here, to create reusable components that application teams can leverage. So ultimately, you're working on code and not servers, even virtual servers. And you want to leverage lighter weight and managed tools to eliminate complexity. The less things you have to manage, the less servers or instances you have to manage, the more work you can do that on your actual product that you're working on. Okay. Okay, so how do you organize your different environments? Well, first you want to organize by environments and layers. So let's talk about environments first. In this example, we've got 4 different environments: prod, integration, and 2 dev environments. And those should really each be their own CloudFormation stack. On top of that, we also have different layers of stacks. So we're breaking down our application into front-end services, back-end services, shared services, base networking, and identity. And these should also be different stacks. So you should have one stack for identity that manages your IAM users, groups, and roles. You should have another CloudFormation stack for your base networking. This defines your VPCs, internet gateways, VPNs, and NATs. And then your shared services stack. So this has your common monitoring, alarms, like your security groups, as well as your databases. And then you've got your backend services, which in this example will handle search, payments, reviews, recommendations, and your front-end services, which is your actual website and your mobile backend. So once you have this layered architecture, you can reuse those same templates to replicate them in different environments, such as the environments we have here, which is Dev 1, Dev 2 integration, and prod. So another thing we want to do here is apply service-oriented architecture. So instead of having one monolithic app, in this example, we've broken down our app into different pieces, different microservices. So we've got 2 different websites, we got different services under those websites. And what this allows us to do is to have smaller applications. We can deploy faster, and those applications can each be functioning on their own. So, for example, if the customer DB service, if something goes wrong with it, our application is loosely coupled, so the whole architecture can still operate in a degraded state, even if one of the underlying services is still down. This also allows us to deploy faster, since deployments are more granular, and since you're doing deployments toward single, smaller services instead of this whole monolithic application that you had before. So another thing that I want to mention here with CloudFormation is nested stacks. So a nested stack allows you to create a tree of stacks. So when you author a template, you can reference other templates inside of it. When you create a stack from the top level template, a tree of nested stacks is automatically created based on the templates you've referenced in it. A prime use case for stacks is reusability. So you want to maintain a common pattern in a single template and reuse it in many different stacks. Instead of copy and pasting the same code over and over again into different CloudFormation stacks, you can just use nested stacks as well. So let's talk about some next steps here. What I would recommend is taking a look at, again, Inspector to integrate security testing into your application lifecycle management. I would take a look at Lambda. So as you break down your application into smaller and smaller pieces, some of those pieces you'll be able to get rid of your instances in general and use Lambda, which is a serverless service. And so what that means is you can take pieces of code in currently Node.js, Java, or Python, and as well as .NET, and just run those as needed in parallel, and you end up paying by the 100 milliseconds and not by the hour like you do with EC2 instances. But also take a look at AWS WAF. So AWS WAF allows you to filter out various kinds of bad actors and malicious traffic out of your application. And again, you can also use your information that you get from things like CloudWatch to inform your WAF rules as well. So those are next steps to look into after you're comfortable with configuration management here. So thank you for attending the webinar, and thanks for your time.